dx equals to ax plus by plus, you take it as like this, a2x plus b2y plus c2. Okay. So like this in the fraction form, they will be, if they are like this, then we can easily identify that these are the non-homogeneous differential equation. Okay. So non-homogeneous differential equation, for finding the solution for this, you have to convert this non-homogeneous differential equation into differential equation. Okay. So for that, you have to find here values will be there, a1, b1, c1 and a2, b2, c2. For finding that values, we have to substitute small x equals to capital X plus h and small y equals to capital Y plus k. Then you have to find these h and k values, and if you substitute in this given equation, then it will be converted into homogeneous differential equation. So whenever it is converted into homogeneous differential equations, same, you have to put y equals to bx, and you have to convert that into, again, same solution procedure will be there. So this is one part. This is the important one. You may have the question on 10 marks on homogeneous or non-homogeneous. Okay. So next we have linear differential equation. I have told that dy by dx plus p of x into y equals to q of x. Like this will be there. Okay. This also you will get for the objective type of question. By seeing this, you have to identify that almost in the map the following they will give. So this is the linear differential equation. So for this, we have to see what is p and what are the q values. Then we have to find the integrating factor, that is e to the power of p dx. After finding the integrating factors, general solution is y into if is equals to integration of q into if plus c. Okay. So whenever it is the linear differential equation, it should be in the form of like this. If it is having somewhere here x square or something, anything, or 2 into. So if it is not in the linear differential equation, you have to convert that into linear differential equation, and you have to identify what are p values and what are q values. Then you have to find integrating factor, and after that the general solution formula is y into integrating factor equals to integration of q into integrating factor plus c. Okay, this is about linear. If we have dy by dx plus p of x into y equals to q of x into y to the power of n, this is called as Bernoulli's equation. Okay, so whenever it is a Bernoulli's equation, so first you have to eliminate this y to the power of n on q of x, and you have to convert this Bernoulli's equation into linear differential equation. Then same procedure, you have to find the integrating factor. So you are not able to listen, huh?
It is audible, ma'am.
That someone is messaging that they are not unable to listen. Okay, so almost the sound is almost, it is high only. Okay, so whenever it is a Bernoulli's equation, you have to convert that into linear differential. That means you have to eliminate this y to the power of n. In linear differential equation, you are not having y to the power of n. Okay, so that y to the power of n, you have to take it as some t or anything, and then u anything you can take. Then you have to convert that into linear differential equation. Then same integrating factor and general solution. Okay, so these are the very important in block 2. So from this, almost whatever the starting we are learning the variable separable method, that is applicable in these all 4 methods. So whenever you convert them into one form to another form, so you will be using them variable separable method in the middle, and then you will do the integration and you will find the general solution. Okay, these are about the unit 5. And last one is the 6th one is the exact differential equation. Okay, this is also important one. In this one method, that is almost all the problems will be there. Here also integrating factor will be the main important one. So this whatever the differential equation will be there, it will be in the form of m of x comma y, okay, into dx plus n of x comma y into dy equals to 0. Okay, so whenever we'll find dou, this is a partial fraction, dou m by dou y, dou n by dou x. So when you take what is the value of m and what is the value of n, if you find the partial differentiation of these two, if both the values are same, then we call it as exact differential equation or exact equation. Okay, whenever you will not get it as both are different values, we call it as non-exact differential equation. Okay, so whenever it is non-exact, exact differential equation means direct you will have the formula for finding the general solution. Okay, some different steps will be there. How we are using the identity factor, that is the integrating factor for linear differential equation. In the same way, for exact differential equation also, some terms will be there to find the general solution. Okay. So if you are getting both the values as not equals to, then we call it as a non-exact differential equation. The main aim is you have to convert non-exact to exact. The procedure how to convert non-exact to exact differential equation is that we'll use the integrating factors. Okay, we'll use the integrating factors. After finding the one integrating factor, you will multiply that integrating factor to the whatever the equation will be there. Given question will be there. No, if you multiply with that integrating factor, then it will be converted into exact differential equation. Again, if you find dou m by dou n, you will get both the values as equal. Okay, that is the process of finding the in the exact differential equations. Okay, so many almost some inspection means by seeing the problem itself, you can identify the integrating factors. That is one method is there, and another 4 methods are you will by seeing the question you have to identify whether mx plus ny. This is one integrating factor, mx minus ny. Yesterday I have told this one 1 by m into dou n by dou x minus dou m by dou y, or 1 by n into dou m by dou y minus dou n by dou x. Okay, like this you will have the 4 integrating factors. By seeing that question, you have to identify which integrating factor is suitable for that one. Then you have to convert this non-exact to exact, and you have to find the general solution. So from unit 5 and unit 6, 2 questions you will get for the, that is 10A and 10B. Okay, this is about the block 2. Now we'll go to the block 3. So block 3 is the differential equations of first order and higher degree. Okay, so first order will be there, and the degree of that, whatever the differential equation is there, it may be 1 or higher than y, higher than 1 value. Okay, so next unit 7, in this, it is differential equations of first order and of degree higher. So main thing is, in this another topic is orthogonal trajectories. Okay, so orthogonal trajectories, you may get for the 10 marks question in this. So in unit 7, what is the definition of the differential equation of first order and the degree higher than 1 means an equation of the form like this: f of x comma y comma p to the power of n. Okay. So if any given differential equation is in this form, f of x comma y comma p to the power of n equals to 0, then we call where here x is the independent variable. X is independent. Yesterday we have seen this is the dependent variable, and here p, whatever p is there, the p value is dy by dx. Okay. So these, if a differential equation is in this form like this, x comma y comma p to the power of n, and here n is always greater than 1. Okay. So n will be greater than 1. So such type of whatever the differential equation you will get, that is called as a differential equation of first order and degree higher than 1. Okay. In these 3 different methods are there. That is the first one is solvable for p. Solvable for p. Next one same solvable for y, and third one is the solvable for x. Okay. So for these 3 different topics, you have different methods are there how to solve such type of problems. So by seeing the question, you have to identify that equations solvable for p will be there, equation solvable for y, equation solvable for x. Okay. So p, how you have to identify means here n is greater than 1. No. So in that it will be in the form of one of the algebraic expression. Okay, algebraic expression, how it will be there, ax square plus bx plus c equals to 0. So here our main term is p. So you may have p square x plus p y plus c equals to something constant value. So it will be in the form of algebraic expression. Then you have to factorize that one. So if how you will be there, if it is 4x plus 2 equals to 0 is there. So how you will write x square plus 2x Here if it is 4 is there, you think. So 4x square. So 4x square means you can write 2x into 2x. That is 2x into 2x is 4x square plus 4 equals to 0. So if you take out common, x plus 2 into x plus 2 equals to 0. So x plus 2 into RS. This is the x plus 2 whole square equals to 0. Like this also you can do. So if any algebraic expression is there, will you do the factorization of that and you will find the roots. The roots are minus 2 comma minus 2. Okay. So same similar way for equation solvable for p also, they will be in the form of p square x. That is, you may have, or else only p square will be there. P square minus p square pxy. So x and y both the variables will be there. So like this pxy plus c, any constant term equals to 0. So that depends on the given question. Then you have to factorize that one and you have to find the roots of that and you have to find the general solution. That is the equation solvable for p. Okay. So example problems you have in your textbook. Already the given question may be in the form of factorization also. P square minus px plus py minus xy equals to 0. You may have constant of or else you may have like this. Okay. So this is the given problem. So you can see higher p square is there means you can, in the question they will not mention directly what the problem will be given, solve the equation. Okay. They will not mention is this question is applicable for p, equation solvable for p or y for x. By seeing the question, you have to identify and you have to use the method. Okay. So for p, you see that p square will be there, p, x and y values and xy. And it can be solved with the help of the factorization. So here already it is in the form of factorization. Just you take the common terms. Okay. You will take here p common, p minus x plus if you will take here y common, p minus x equals to 0. Then we got p minus x into p plus y equals to 0. So what we got, p equals to x, here p equals to minus 1. So what is p? P is dy by dx equals to x. Here also dy by dx equals to minus 1 on integrating. Okay. So on integrating, what you will get, dy by dt. So now here we have to use the variable separable method. So both the variables are not the same, no. So just you do the by variable separable method. You do the cross multiplication. You will get dy equals to x into dx. Here dy by this y equals to minus dx. Okay. So now these two are the same terms. Here it is y and here these two are same. So use this variable separable method. Now on integrating. Okay. You will get y is equals to, that is integration of dy equals to integration of x dx. So it is y equals to, this is x square by 2 plus 1 constant c1. So if you do this second one, that is integration of 1 by y dy is equals to integration of dx. So this is log y. This is minus x plus c2. This is the constant term for this one. And this is the constant term for the second term. So when you write it as a general solution, we'll write it as, that is two values. You can take this cross multiply, 2y minus x square. X, or else you can write x square minus 2y plus c. You take out these two constants, that is c1 is and c2 both are equals to only one constant. Okay. So then you can write the solution for this one as x square minus 2y plus c into this one is. And this log, if you take that side, what will happen? Y is equals to e to the power of minus x plus c. So this is y minus e to the power of minus x plus c is equals to 0. Like this, you have to write the solutions for this one. Okay. So this is one method for equation solvable for p. That is, if we can do the factorization of the given differential equation, then we can apply this method. Okay. If we are unable to do, means only one, you will get the solution. Another solution, if you are not getting, means different methods are there for solving equations of solvable for y and also equation solvable for x. First one you remember, if factorization is done means you can apply this method. So if factorization is not possible for the given differential equation, you can use these two. And you have to, how can you identify this is solvable for this or this means? Here, whatever the degree is there, degree of x term in the given question will be only 1. If x term it is having only degree 1 means you can use this method. If y term it is having degree 1 means you can use this method. Okay. So factorization means this method. If factorization is not possible means these two you have to apply. Okay. So solvable for y and also solvable for x. You have the example problems in your textbook. Okay. Next, another one is, this is only 5 marks question you will get. Clairaut's equation. Okay. It is a Clairaut's differential equation. Okay. So this will be in the form of, if the given question is in the form of y is equals to xp plus pi of p. Okay. So if the given, this you will get only 5 marks question, only one 5 marks question you will get in the section A. Okay. So y equals to xp plus pi of p, even you will get one, that is a objective type of question also you will get. This Clairaut's differential equation E will be in the form of y equals to x into p plus pi of p. If you take it as a equation 1, if you differentiate this dy by dx, what is dy by dx? P, no? So this is p is equals to, these two are both the variables. So x into dp by dx plus x value is 1 means you will get p plus pi dash of p. Okay, when you differentiate that, you will get this, and here dp by dx value, that is this p and this p both will get cancelled. So it will be, that is x into dp by dx plus pi dash of p is equals to 0 you will get. Okay. So that if you simplify, you will get the dp by dx equals to 0. So dp by dx equals to 0 implies we get dp is equals to dx. On integrating, you will get p is equals to c value you will get. This is 0, no? Dx into 0 means dp equals to 0. On integrating this one, that is integrating dp. So you will get it as, that is p is equals to, this is the constant term. So 0 means you are taking that as a constant term. On integrating, you will get p is equals to c. That if you substitute here, y is equals to x into c plus pi of c. Okay. Clairaut's differential equation, whenever it is in this form, directly you have to substitute p value as c. That means wherever p is there, if you substitute c, it's enough. That will be converted into Clairaut's differential equation. So this 5 marks compulsory you will get. So if it is not in the form of Clairaut's differential equation, then some other procedure will be there. That is somewhat lengthy one that you can see in the textbook. Okay. So if directly it is in the form, you can easily apply this method. So it is page number 135 you have. So Clairaut's differential equation, first definition is there, a differential equation of the form. So here also you get dp by dx. Okay. So this p, dy by dx equals to p, and here you will get 1 p, no, both will get cancelled. So what will be left? Dp by dx, if you will take common, x plus pi dash of p is equals to 0. That means this term is equals to 0. dp by dx is equals to 0, comma, x plus pi dash of p equals to 0. This you can't find the solution, so only we'll use this one. dp by dx equals to 0 means dp equals to 0, and integrating you will get p is equals to c. Substitute this p in this one, then you will get the general solution of the given differential equation. Okay. So direct, if the problems are like this, you can follow this method. If the given problem is not in direct form, then last you have see. For example, if the given equation is of the form y square equals to pxy plus f of py by x. So it is not in the form of Clairaut's standard form. Then you have to put x square equals to u and y square equals to v, and that whatever the procedure is there, You have to follow that and you have to find the solution of this. So these three topics are important. So this question is the compulsory question. You will get Lorentz differential equation, and you may get the problems on solvable for P and also Y and X for 5 marks questions. So in this, the main thing is about the orthogonal trajectories. So you have the definition of what are orthogonal trajectories. That is a curve which cuts every member of given family of curves at right angle is called as, means a curve which cuts every member of the given family of curves will be there. They may give the parabola, they may give the ellipse or a circle equation they will give. So like the different family of curves will be given. If a curve cuts those family of curves at right angle, then we call it as an orthogonal trajectories. Okay, so we know no need of the definition, just to understand the concept, it's enough. So the whatever the working rule is there for finding the orthogonal trajectories is, first you have to, means in the question itself they will mention that solve the orthogonal trajectories of the curves. Some curve will be given. So after seeing that curve, so it will be in the almost like this, it will be formed f of x comma y comma c is equals to any constant term will be there. Okay, so if we'll take the given curve as the equation 1, then first step is for orthogonal trajectories. Okay, first step 1 is differentiate 1 with respect to x on both sides. Okay, so when you differentiate 1 with respect to on x on both sides, what you will get if y square y is equals to some x square plus y square is there, or else y square equals to 4x is there, or parabola is there, no, x square equals to 4ay, means you will get the compulsory, when you differentiate you will get the dy by dx. No? Okay, so in place of second step is, step 2 is replace wherever dy by dx is there, dy by dx you have to replace it by dx by dy. Okay, this is the second step. So dy by dx by minus dx by dy, and then step 3 is we have to use variable separable method. Okay, that means like terms, whatever x terms are there, you take one side, and y terms you take another side, then integrate. Then integrating on both sides, we get general solution. Okay, main thing is second one is the main one. If you replace the, if you will not use the second one, you will not get the solution. So first one is doing the differentiation for the given one, and the second one is replacing dy by dx by minus dx by dy, and third one is by using the differential, there is a variable separable method. You have to separate the variables and then you have to do the integrating. So if you do the integration of that one, then you will get the answer. Okay, so you can see this one, simple one, xy, if the family of the curves is given as xy equals to c. So first one, solution of this is differentiate 1 with respect to x on both sides. These two are this is independent variable, this is dependent variable. So you have to apply the UV rule. That is x into dy by dx plus y into x differentiation is 1. Okay, so this constant differentiation is 0. So x into dy by dx is equals to minus y. Now replace dy by dx by minus dx by dy. Okay, so what will happen? Minus x into dx by dy is equals to minus y. So minus minus you can cancel on both sides. Now separate the variables. So this is already in the form of x into dx equals, if you do the cross multiplication, y into dy on integrating. Okay, so that is x into dx. If you take inside this one, this side, okay, minus y into dy is equals to c constant. So x square by 2 minus y square by 2 is equals to c. This is the solution of the orthogonal trajectories. Okay, so if you do the cross multiplication, you will get x square minus y square equals to c. 2 into c you can write, or The main thing is constant of integration is c. So if you do the cross multiplication, you can write that this 2c is equals to c only. So x square minus y square equals to c is the orthogonal trajectory of the given curve xy equals to c. So main procedure is this one. If you follow these steps, it's enough. So you may get this one for 10 marks question. That is it is a third block, no? So 11A. This before one, whatever we have seen in this solvable for x, solvable for y, solvable for p, and also Claudiet's equation, those are the 5 marks question, and orthogonal trajectory. This is the small one I have told. Some problems will be somewhat lengthy one. So such type of lengthy problem, they will ask for the 10 marks question. Means here it is a simple one. So we have done the aim is to eliminate the arbitrary constants. Compulsory one arbitrary constant will be given in the question. You have to eliminate that one and you have to find the orthogonal trajectories. That is the procedure for finding the orthogonal trajectories. So this is about the 7th unit. See the example and also exercise problems. And also MEQ questions. That is the model examination questions. Next to unit 8. So unit 8 is also one you will get for the 10 marks question. So in block 2, 7th unit and 8th unit, you will get the that is a 10 marks question, 11A and 11B. Okay. So simultaneous differential equation, you have the definition in your textbook. If they are in the form of P dx plus Q dy plus R equals to 0, such type of differential equations are called as simultaneous differential equations. So this problem also, that is 11B question you will get, that will be the 10 marks question. So from the 8th unit, you are not having the 5 marks question, only one 10 marks question, you will get that one. That is P dx plus Q dy plus R equals to 0. Okay. Such type of equations, differential equations are called simultaneous differential equations. So in this, different methods are there for solving the problems. So you can see those in the textbook. And next one is simultaneous linear differential equation will be there. This is simultaneous only differential equation if we have simultaneous linear differential equation. So that will be the form of like this dx by p is equals to dy by q equals to dz by r. Okay. So if such type of problems are given, then we call it as a simultaneous linear differential equations. So for this one, same steps will be there how to solve this problems. So first step is you have to take any two ratios. Here 3 ratios are there, no? Or we call it as a first term, second term, or third term. 3 terms are there. So first you have to take any 2 terms, that is first and second, or second and third, or 1 and 3. Okay. That is dx by p is equals to dy by q, or dy by q is equals to dz by r, or third one is. Okay. So first if you take these 2 terms, then you have to do, that is by taking these 2 terms, you have to apply the second method, that is a variable separable method. With the help of the variable separable method, you have to take the, what is the aim of the variable separable method? We are separating the variables like terms to one side. So q into dx is equals to p into dy. That means here also y term will be there, here x term will be there. When you do the cross multiplication and you separate the variables, if you integrate that one, then you will get 2 solutions. Okay. First, if you take these 2 terms, you will get 2 solutions. If you take these 2 terms, you will get another 2 solutions. Okay. Then we write the general solution of that one. Okay. Take any 2 ratios and by variable separable method, integrate, and if you find the solution, you will get here with constant 1 C1 and with constant C2, it is equals to 0. This is the general solution of this one. Okay. Either you can take these 2 terms or either you can take these 2 terms. But the solution to find is only we have to get the 2 constant, means you have to get the 2 solutions. Okay. So that is the main important in simultaneous linear differential equation. This type of problems you will get for the 10 marks question. So one thing is when you take the terms, after doing the variable separable method on integration, if you get the solution, this is one method. In some problems, when you take two terms, only one term, maybe we can do the integration. Second term, it may not possible to do the direct integration. So such type of that, whatever the solution here you will get, that means C1 value you will get, no, that you have to substitute here and then you have to find the solution. This is the second method. And third method is both you can't do the integration. Then one more procedure will be there, that is called as, that is cross multiplication will be there, L1 into dx plus N1 into dz by L1 into P, M1 into Q plus N1 into R is equals to 0. That means with some multipliers will be there. That multipliers you have to multiply, L, M, N are the multipliers will be there. That if you do multiply with the dx, dy, dz values and also with p, q values, then you can do the integration. Okay. If we have the chance of finding, that means up till we may, this is the 8th unit, no? So if you go for the 8th unit, so if you have time, you'll see one problem on this one, finding the means actually it is a very easy one. Question will be in this form. You have to take any two terms, then you have to do variable separable method and you have to find the solution. Okay. So first method is easy one. Second method only, if you are not getting the integration, whatever the first term you are taking, no, first two ratios, you will get some value. That value you have to substitute in the second one and you have to find that one. And third one is this one. Okay. So on first method, second method and third method, you have the three different problems. Example problems are also there in your textbook. Okay. See that one. This is one simultaneous linear differential equation is 10 marks question. So next in this 9th unit we have. So 9th unit is very easy one. One 5 marks question you will get. So one more topic is there in the 8th unit only. It is total differential equations. So total differential equation means, so see from the textbook, it is a very lengthy one. See page number 163, 164, 65, 66. These are all example problems. Now whatever I have told the methods, no, that example problems are this one. And 169 page number, you have total differential equations. Here 1 to 12 are there, no? These are useful for the objective type of questions. Okay. So if round up these all 1 to 12 formulas, so you can apply anywhere to solve the differential equation. And after that, 172 page number 8.6, condition for integrability of the total differential equation. P dx, this is there, no? Differential equation P dx plus Q dy plus R dz I have. Dz equals to 0. So such type of simultaneous differential equation, one condition will be there. In the theorem it is there, no? That will be their condition. If you substitute those values, if we get the value as 0, then whatever the differential equation is there, the condition of integrability is applicable will tell. Okay. So you can see the example for that one. So this is also question you will get for, sometimes they will ask for 5 marks question. So these are the topics in 8th unit. If you will go to the 9th unit. So 9th unit is homogeneous linear differential equations of second and higher order with constant quotients. So here, if you understand in unit 9, the concept of this one, then this same concept is useful for 10th unit and 11th unit. Okay. So if you understand here the concept, so same one you can apply for those 2 units also. So here homogeneous linear differential equations of second and higher order. So you may have the second order or higher means that is cube may you have, or d to the power of 4 also will be there. So here you will have the higher order differential equations, and also homogeneous means how to represent that one. Okay. So first thing is a linear differential equation of order n with constant quotients is of the form y to the power of n plus a1 into y to the power of n minus 1 plus a2 so on equals to b of x. Okay, this is the linear differential equation of order n with constant quotients. Okay. So the given problem will be in the form of y to the power of n plus a1. a1 is the constant term is that a1 y to the power of n minus 1 plus a2 y to the power of n minus 2 an. This is the last term equals to b of x. This whatever the LHS side and this is the RHS side. This is LHS and this is RHS. Okay. If LH will represent this LHS term as L of y. Okay. So if we'll take this of L of y and equals to b of x. Okay. So this L of y is equals to b of x. It represents the linear differential equation of order n with constant quotients. If b of x value is equals to 0, this b of x is equals to 0, then L of y equals to 0. That means you are substituting here b of x value as 0. So what will happen? This L of y is equals to 0 is called as a homogeneous linear differential equation. Okay. This means this is called as homogeneous linear differential equation. That means here b of x value is not there. Then we call it as a homogeneous equation or else homogeneous linear differential equation. Okay. So on these problems will be there. And here this whatever y to the power of n means you may have like this d square y by dx square plus 4 into dy by dx plus 4y equals to 0. Means this is y square plus 4 into y dash plus 4y equals to 0 if you write on this form. Okay. So we'll represent here it as either, you know already that whenever y of x equals to y is any function, y equals to f of x is any function, we will find the differentiation of that one. Either will represent as like this, y dash or dy by dx or f dash of x. Okay. So here we can use like this or we can use like this for the differentiation of the derivatives. So you may have questions on like this or like this and even d square will be there where d represents the d by dx. Okay. This is called as a differential operator. This is differential operator. So problems will be asked on the, means they may be in the form of like this or like this or like this. Okay. So the meaning of these three is same only. You can use with the help of differential operator or with the help of y term or with the help of the dy by dx. Problems will be like this. You may represent it as d means this one. If it is d square means d square by dx square. It is d to the power of 1. Okay. So questions will be asked for 5 marks question. Homogeneous linear differential equation. Whenever it is a non-homogeneous linear differential equation means this b of x is not equals to 0. Some value will be there. Okay. So this whatever problems are there in the unit 9, they are very simple one. That means here if you before we have seen the problems now. If you write this one in the y form, d square y by square x square means y square plus 4y dash plus 4 equals to 0. Or if you write in the differential operator, d square plus 4d plus 4 into y equals to 0. Same one we have done factorization. No? For this one, this is the given homogeneous equation. For homogeneous equation, you have to convert into this is called as auxiliary equation. Auxiliary equation means in place of d, you have to substitute either you can take r or n or t, anything you can take variable. It's your wish. but in the textbook, almost R and M they are using. Okay. So either you can take auxiliary equation in the form of R or in the form of M. So if you take it in the form of R square plus 4R plus 4 equals to 0. Okay. So I am telling the procedure for finding the general solution of the homogeneous equations, homogeneous linear differential equations. So whenever it is in the form of like this or like this, you can write as this d square plus 4d plus 4 equals to 0. The auxiliary equation is in place of d, you write r. So when you do the factorization, just now we have done no d r square plus 2 whole square equals to 0, means you will get the roots of this equation is r equals to minus 2 comma 2. So pi 1 of x is called as an independent solution. Okay. So your first solution is that is minus 2. Next second solution is pi 2 of x is minus 2. Okay. So if you think instead of here what we have, so if we have different terms, so here also conditions will be there. D square plus 5d plus 6 is there. 6y equals to 0. Okay. If you have the question like this, d square plus 5d plus 6 equals to 0. Then what you'll write? D square plus 3d plus 2d plus 6 is equals to 0. Okay. 6 into d square means 6d square. 3 into 2, 6d square, you will get product of the terms, these two, and addition of these two terms you will get in the middle. I hope so you know the factorization. So what you will get the terms d plus 3 plus 2 into d plus 3 equals to 0. So here we got d plus 3 into d plus 2 is equals to 0. Here we got different, no? Sorry, we have to write this one as r square, no? That is auxiliary equation is r square plus 5r plus 6 equals to 0. So this is r square plus 3r plus 2r plus 6 equals to 0. Here you write instead of d r. So this is r plus 3, r plus 2. So what we got, r equals to minus 2 comma minus 3. Here we got the roots as different, distinct roots we got. Okay. So first linear independent solution is pi 1 of x equals to, we'll write the solution as that is e to the power of minus 2x. Okay. Next linear independent solution is pi e to the, that is pi of x is e to the power of minus 3x. Okay. General solution is y is equals to constant term. Here we got two roots now. So whenever we have the order of 2, you will get the 2 constant terms. When you have the order as the 3, you will get the 3 constant terms. If you have the order 1 means only 1 constant term you will get. Okay, you remember that one. So the general solution is C1 into e to the power of minus 2x plus C2 into e to the power of minus 3x. Okay. So this is the procedure of finding homogeneous linear differential equation. So if you know this procedure, first one is for the algebraic expression, we'll find no ax square plus bx plus c equals to 0. That is ax square plus alpha plus beta. And also you will have alpha into beta. Alpha and beta are the roots of the algebraic expression. So sum of the roots and product of the roots will be there. Similarly, here also, if you add these two values, you have to get the middle term. If you multiply these two terms, you have to get this last two terms. Okay. So if you do the factorization of that, you will get the two roots. If the roots are distinct, means here minus 2 is there, minus 3 is there, we can separate this as solutions. This is one independent, linear independent solution, and this is the second linear independent solution. Then general solution. Okay. So in this, you may get 3 different types of the roots. These two are real and distinct roots. If you have idea, 8th class, you have the, in the algebra factorization is there. In that you have the roots will be real and distinct, real and equal, and also complementary roots will be there. that is they will be in the form of a plus ib. That is one is the real root and another one is the imaginary root will be there. So three types of the roots you will get. First one is real, two roots, real and distinct, means a different one. And second one, two roots, real and equal. Both will be same. That is r equals, you may have 2, 2, r 1, 1, like that you will have. And third one is complex or imaginary. They will be in the form of alpha plus I beta equals to 0. Like this. Alpha is the real one and beta is the imaginary root. So then, if they are real and distinct, we'll write the general solution as like this. General solution is y equals to c1 e to that is r plus c2 e to the power of beta x. Both are same. Means these are real and also equal. Okay. So whenever you take a and b, both are the roots. Okay. So here the general solution is y equals to c1 x into the power of 2x. Please self. Okay. Whenever the two roots are real and equal, means both are same you are getting. Then the general solution is y equals to c1 plus c2 into x e to the power of whatever the root you are getting, that only one you have to take. That is e to the power of 2x. And if you have the roots as in the form of a plus ib, that is alpha plus I into beta is equals to 0. For that one, we'll get it as that is y. General solution is y equals to e to the power of alpha x into c cos beta x plus d sin beta x. Okay. So like this you will get. You can take the one example. If it is in the form of minus 1 plus r minus 2y. So minus will be there. Minus 1 plus r minus 2y. If you got for some any differential equation, this as a root. Then how you will write? Y is equals to e to the power of alpha value is minus 1. That is minus x into c the constant term. Cos here, what is beta value 2? That is c cos 2x plus d sin 2x. Okay. So these all different, whatever the three types of roots is there, we will have different type to write the general solutions. So you have to remember this one. This, if you know the concept, you can do for the 10th and 11th unit all, and even 12th unit also. This same concept is applicable. Okay. So this is the important one. 1 5 marks question you will get compulsory for the, that is in the section A you will get. And section B, if you'll see, that is a combination of, just now we have seen L of y equals to b of x, no? If b of x equals to 0, we call it as a homogeneous one. If in the b of x some value is given, then we'll find the, that is a particular integral will be there. If you have idea in intermediate, I think so it is there. Particular integral concept is there. So whenever it is a non-homogeneous linear differential equation, that type of question you will get for the 10 marks one. Okay. So nothing but here it is question is there, no? Same. This is the homogeneous. Right here. That is d square plus 5d plus 6 of y equals to 0 means it is homogeneous. Okay. So if instead of that d square plus 5d plus 6 into y is equals to e to the power of x plus x square. That means b of x, you have some value. Then such type of problems are called as non-homogeneous linear differential equations. Okay. So only if it is a homogeneous one, we are finding, that is we are converting it into auxiliary equation. After converting the auxiliary equation, we are writing the general solution. Okay. Only 2 steps we are doing. But when it is a non-homogeneous linear differential equation, first thing is we have to write auxiliary equation. Auxiliary equation is nothing but only we have to write only homogeneous. That is d square plus 5d plus 6 equals to 0. Only you have to take, not this right hand side value. That means homogeneous part only we have to take, and you have to convert it into auxiliary equation. 5r plus 6 equals to 0. Okay. So then for this, after finding the roots, here we call it as general solution. No? Here we call it as complementary function. We call it as a complementary function, or in the short form, we write CF. So CF, here we have written general solution. No? That it is called as complementary function. That will be in the form of C1 e to the power of x plus C2 e to the power of x. That is 1x or 2x, depending on the roots, or you can take A into B. Okay. So this is the first part of the non-homogeneous. So only for the LHS we have find the solution. Now we have to find the solution for the right hand side value also. That is called as particular integral. That is short form, you can take it as PI. Okay. So PI is equals to 1 divided by the differential homogeneous part is there, no? That one, that is d square plus 5d plus 6 into whatever bx value is there, that value, that is e to the power of x plus x square. Okay. So this you have here two terms are there. If you think only one term is there, only e power x is there. Okay. So instead of these two, you may have one term you may have in the right hand side, or you may have two or even three also you will have. That is e power x will be there, x square will be there, one trigonometric function also will be there. Okay. Such type of problems will be also there. In some cases, only one term will be there. So I am telling only for your example, if only e to the power of x is there. If three terms are there, means you have to split this one. That is this part into e power x, and again this one, numerator and denominator into x square, and again numerator and denominator into sin x. Okay. For solving these problems, the rules will be different. If e power x is there, means one rule will be there. X square means another rule, and sin x means another rule. Same rule is not there for solving the problems. So if e power x is there, means directly the quotient of x here, you have to substitute here, then you will get the answer. But if it is x square, means you have to take here a d square common, and you have to convert it into 1 minus d square to the power of minus 1. And then you have to do the multiplication. So while solving the problems, you will understand the concept. Even sin x also like that only. Okay. So for having the terms here different, the procedure will be different one. So particular integral, if e power x is there, means whatever the quotient is there, you think it here 2 is there. So 2 means you have to substitute in place of d, you have to substitute that value. That is, it is equals to 1 by 2 square plus 5 into 2 plus 6 into e to the power of 2x. Okay. So it is e to the power of 2x by 4 plus 10 plus 6. So e to the power of 2x by what we got? 20. Okay. This is the particular integral value. So now general solution, last one. General solution is equals to complementary function plus particular integral. That is here whatever you got the this value and this, that is y equals, sorry, general solution is y equals to c1 e to the power of ax plus c2 e to the power of bx plus 1 by 20 into e to the power of 2x. So like this you have to write the general solution. So this, whatever the non-homogeneous linear differential equations will be there, you are finding two parts, no? One part is a complementary function, another part is a particular integral. So such type of problems will be asked for the 10 marks question. In simple one, only if one term is there in the right hand side, such type of problem they may even ask for the 5 marks question. Okay. So this non-homogeneous you have in the 10th unit, it is there. 9th unit is only for the homogeneous one. Okay, in homogeneous, you have many example problems. Even from the homogeneous one, you will get the 2 objective type of questions also. So simple one like this, any differential equation will be given. They will ask what are the linear independent solutions of this one. Okay. Or write the complementary function of this one. Because it is homogeneous, no, it equals to 0. You need to find only the roots and then we need to find only the complementary function. Okay. So 2 questions you will get in the objective type of questions and 5 marks question is a compulsory one. Okay. So in this only unit, you have the concept of Vronsky equation. So Vronsky equation is nothing but it is represented as W of P1 and P2. That is will represent it as Vronsky equation W of phi1 comma phi2. Here we got independent solutions. No, just now I have updated one. That is, we'll get here after finding the roots. First root we call it as that is first one phi1 of x, something we will get e to the power of x. Phi2 of x, it is called as e to the power of bx. We'll get the 2 solutions. These 2 are linear independent solutions. We'll write the Vronsky equation as g is equals to determinant of phi1, phi2 into phi1 dash, phi2 dash. Okay. So that is these 2, whatever the values are there, those 2 differentiations. So it is equals to phi1 into phi2 dash minus phi1 dash into phi2. Okay. So this is the Vronsky equation. This is useful for finding the non-homogeneous differential equation of the variation of parameters will be there. Another topic is there that you have in 10th and 11th unit. For that, we use this concept. Only simple one, if 2 solutions are given, phi1 and phi2, you got here, no? They may ask to find the Vronsky equation. That is, you have to find, substitute in the determinant and you have to find the value. Okay. So if this value is equals to 0, means after writing these 2 and after writing the differentiation, if this value equals to 0, if you are getting, this is called as linearly independent solution, we call it as. Then the given roots are linear independent. If we get this value as not equals to 0, then we call it as a linearly dependent solutions. Okay. So that concept also we will get in the objective type of questions. So this is about the 9th unit. You see the example problems in 199, 200 you have, and even in the check your progress and model examination questions. I hope you understood this homogeneous concept. You can solve this, whatever the example problems in there in your textbook and MEQ questions. So if you understand this concept, only you find the complementary function. Just not go to the particular integral. If you solve this example problems on complementary function, you will score with 7 marks. You will get 5 marks question is from section A and 2 objective type of questions you will get in the section C. Okay. So if you have time, so practice that one. But because already I have told one problem on that, 2 problems we have done. So you can understand that and you can solve the problems. Okay. Next, last 4th block is about non-homogeneous equations of 2nd and higher order. And one more concept is partial differential equations. Okay. So non-homogeneous, just now I have told, no? If we have on the right hand side some value, then we call it as a non-homogeneous one. That further you will have the complementary function and also particular integral will be there. That is only there in the textbook. 205 page number you have. 205, 6, 7, 8, 9. Okay. So whenever the right hand side value is e power x, one rule will be there to find the particular integral. If x square is there means another rule. And if cos x or sin x or secant x, you will have another rule. Okay. So that all rules are there in the textbook. They are called it as type 1, type 2, type 3. Different types are there in 209, 210, 11, 12 page numbers. Okay. So if we have time, we'll see one problem on this one. So just now I have told the concept is like this only, but rules will be different. And next one is the concept of variation of parameters. This is one 10 marks question you will get on variation of parameters. So variation of parameters almost somewhat like this only will be there. Up till complementary function, same procedure will be there. So after complementary function, you will get two values. This is one root, this is one root, no? Pi1 of x and pi2 of x. Then we'll find the Wronskian equation of that one. After finding the Wronskian equation, you'll find u1 and u2 values. You can see the procedure here in the textbook, it is there. So u1 will have different formula and u2 will be having a different formula. If you combine them with roots pi1 and pi2, then the problem is solved with the help of the variation of parameters. Okay. So this is about 10th unit. Next, we have the 11th unit is linear differential equations with variable coefficients. So variable coefficients, there we have constant coefficient, no? Here you will have the variable coefficients. That is constant terms you will not have. They may be in the form of anything. So here also same differential equation will be there. One solution they will give in the question. You have to find the second solution of the given problem. Okay. So one solution will be given in the question. With the help of that solution, you have to find the second solution of the problem. So these problems also you may get for the 10 marks of question in the 11th unit. Okay. So in this 233 page number, Cauchy-Euler equation will be there. This is important one. This is also useful. So the given problem will be in the form of, that is x square into d square y by dx square plus 2x into dy by dx plus 2y equals to something will be there. So there, by seeing that, you have to identify that this is a Cauchy-Euler equation. So in page number 233, it is there. Okay. So this is also one. In some cases, they will ask for the 10 marks for. Okay. This is about the 11th unit. These two topics are there. And 12th unit, we have the, there is a 7th, 8th unit, we have done no simultaneous linear differential equation. That concept only will be there. But here we use the multipliers will be there. With the help of the multipliers, we'll solve the problems. And in 12th unit, that is the partial differential equation is also there. No? Partial differential equation. So 8th question in section A will be from formation of partial differential equation. Okay. In the 4th unit, we have formation of differential equation. No? Same procedure will be there for finding the partial differential equation also. So that one 5 marks question you will get, one 10 marks question you will get for the Lagrange's method is there. In this only 12th unit. In the classification. 260 page number is there. Lagrange's method of solving linear partial equations of first order. Okay. So this is one 10 marks question. So if we tomorrow we'll try to see some problems. So which will get for the 5 marks questions and also 10 marks questions. So so in your study centers, anyone have completed any syllabus of the second semester? Do you have?
No, ma'am. No, ma'am.
Not a
They didn't conduct any offline classes for maths or optional classes.
No, ma'am. Which center?
Khairatabad.
Khairatabad classes were conducted, no?
They cancelled for some reason. They told that they are having public exams and all.
Okay. Okay, we'll try to start from the unit 1. Some important topics we'll cover. After that, go to the other also. So, 50% of the syllabus is completed in the offline. We have to start actually from the 4th block. But I hope
But
so.
they didn't complete, ma'am. But they didn't complete.
Okay. I'll start from the unit 1 itself only. So starting to blocks of the one integration, if you have the idea of the intermediate first year and second year, you can do the integration part in the block 1. And second block is also somewhat easy one compared to third and fourth blocks. Okay. So we'll try to complete. Again, 4 classes are there. Tomorrow's 1 class and again 3 classes. There is a 12, 11, 12, 13. So within 4, so how many topics are covered, we'll try to do that one. Okay. So I have already told some of the topics and even problems also I have told in the in between. So which are easy for you. So try to solve those problems from the textbook. So by that you can reduce somewhat syllabus. Okay. So if you have time, each and every topic I have told one example problem. So with the help of that, you can solve the other problems from the textbook of there is a MEQ questions will be there now, model examination questions, and also check your progress will be there. So try to, with the help, check your progress, already solution will be there. So with the help of that, you solve the problems. Okay, tomorrow we'll see the unit 1. Okay.
Ma'am?